I only have 5 minutes, so I'm going to show you a very specific slice of the technology integration we've done with VMware, NSXV, and OVSDB. The proof of concept network is actually set up in our Santa Clara HQ, so hopefully we have a nice fast connection. I can show you as much as possible. What we're really showing here is integration with a hardware switch controller, which in this instance is NSX, and utilizing OVSDB, the open protocol, to be able to control a bare metal endpoint. So be able to provision something that may not be hypervisor or VXLAN aware, i.e. you have some VMs, you'd like to add some storage, a load balance or something into that process, and you want to do it from a centralized orchestrator. So we're using VMware NSX and vSphere specifically to do this. Essentially what we're doing is we're adding a bare metal host over here on an Arista hardware VTEP into a VXLAN domain with the rest of the infrastructure and the software encapsulated VTEPs over in VMware. So essentially the physical looks something like this, which is some software VTEPs running on ESX, and then a hardware VTEP, a physical set of switches, and we're going to provision everything via vCenter. What's cool is, logically, it just looks like a big flat network. So we're kind of obfuscating all the tricks and magic and layer 3 forwarding that's happening here. It just looks like a flat subnet. If you had to look at what it looks like physically, that's what it is. It's a bunch of wires and physical switches. First thing we need to do to be able to do this is to be able to have the NSX controller actually control the Arista switch. So as opposed to showing you all this, we went ahead and pre-provisioned it. We added a certificate for security, brought the CVX instance up in Arista, and then we can bind physical hardware into an NSX vSphere domain. So the way we do that is we go and can click on and attach hardware ports, and that's where I'll cut over to the live demo here. So real quick, if you see hardware devices, you'll see the NSX CVX instance. This CVX is our controller. It's an Arista controller. This is what knows how to talk OVSDB to vSphere. And then logical switches, as you'd expect, we're trying to make this administratively easy. You can go right into your logical switch administration in the vCenter and configure networks. The magic happens when you want to bind a physical hardware port to a logical network, right? Which typically would require some manual plumbing, a decent amount of intervention. So we'll go ahead and grab some hardware ports from the NSX instance. One cool thing about this demo, by the way, is MLAG or redundant architectures would require you to touch both switches. We virtualized both switches into a single switch for representation here, so I'll grab the pair of switches that I want. We'll go ahead and grab the interface that's connected to the bare metal host. We'll select the VLAN that we know the bare metal host is on, which is 2. And we'll go ahead and attach the ports. And at this point, what we've done is we've configured the physical set of switches right from NSX. And this is a very straightforward demo. What's cool is, if you look at some of the mappings in EOS, this is where the operational part of troubleshooting and looking at these environments becomes tricky. We have this feature called VM Tracer, which is right in native in our EOS CLI. We can actually drill down on that encapsulated host. We can tell you its VNIC, its VTEP address, its VLAN, its MAC address, right from the switch. So if you're troubleshooting VXLAN connectivity issues, you can do that right from the switch CLI. You'll also notice that if we look here at the VXLAN interfaces, these are automatically provisioned by the NSX. We have our replication nodes, which is our software hypervisors. And if we look at the MAC addresses received, we'll see that we're receiving these from NSX directly. So how does this happen? Our CVX controller is actually running an OVSD database. It's presenting Arista switches up. It's receiving MAC address information down. It's all an open protocol integration. So direct vendor-to-vendor integration powered by OVSDB, and that's what I wanted to show. If you have any questions, come in. Okay. So one other cool thing about this is, in order to make this work, the switches just need to be pointed at our CVX controller. And VMware has a one-to-one relationship with the CVX controller. You don't have to have NSX talking to a bunch of devices. You have it talking to one controller on our side. And then all of that is pushed down to the switches in a large distributed network. So on our switch side, if we look at this real quick, we'll get a little geeky. Yep, wrong switch. So from our CVX, you can display the VNI, the logical ports, and we can actually display the physical ports that we're advertising out.